Section 1. The universe of weight, from grains to galaxies. Weight. It's a fundamental property of matter. From the smallest grain of sand to the most massive black hole, everything has weight. Measuring weight accurately is crucial in countless fields. Scientists need it for experiments. Engineers rely on it for design. And let's not forget bakers, who depend on it for delicious treats. For centuries, we relied on mechanical balances. These tools, while useful, have limitations. They can be imprecise and susceptible to environmental factors. But fear not, for a cosmic revolution in measurement has arrived. Enter the electromagnetic balance. These marvels of engineering provide unparalleled accuracy and ease of use. They have transformed how we measure weight, ushering in a new era of precision. So, buckle up, fellow space travelers, as we embark on a journey to explore the fascinating world of electromagnetic balances. Section 2. Electromagnetic balances, a cosmic revolution in measurement. Electromagnetic balances sound complex, and in a way they are. But fear not, dear reader, for their elegance lies in their simplicity. Unlike their mechanical ancestors, these balances don't rely on springs or weights for measurement. Instead, they harness the power of electromagnetism, a fundamental force in the universe. At the heart of an electromagnetic balance lies an electromagnet, a coil of wire that generates a magnetic field when electricity flows through it. This magnetic field interacts with another magnet or a piece of ferrous material, creating a force. By carefully controlling the amount of current flowing through the electromagnet, we can precisely counterbalance the force exerted by the object being weighed. This balance point, detected by a sensitive sensor, translates into a digital weight reading. It's a cosmic dance between electricity, magnetism, and matter, resulting in a measurement tool of extraordinary precision. Section 3. Inside the cosmic machine. Unraveling the electromagnetic balance. Let's peer deeper into the heart of an electromagnetic balance. Imagine a seesaw, perfectly balanced. On one side, we have the object we want to weigh. On the other side, we have the electromagnet, our invisible force. The balance also contains a weighing pan, usually made of a non-magnetic material, where we place the object. Below the pan lies the heart of the system, the electromagnet and a position sensor. The sensor constantly monitors the pan's position, detecting even the slightest movement. When an object is placed on the pan, it disturbs the balance, causing the pan to move downwards. This movement is detected by the sensor, which sends a signal to the microprocessor, the brain of the operation. The microprocessor, in turn, adjusts the current flowing through the electromagnet, increasing its magnetic field to counteract the object's weight. This delicate dance continues until the pan returns to its original position, achieving perfect balance. Once equilibrium is reached, the microprocessor translates the current required to achieve this balance into a digital weight reading, displayed on the screen. It's a symphony of physics and engineering, all working in unison to provide an accurate measurement. Section 4. Hanging balances, weighing the universe, one drop at a time. Electromagnetic balances come in various forms, each tailored for specific applications. One such type is the hanging balance, a marvel of precision often found in laboratories and research facilities. As the name suggests, hanging balances suspend the weighing pan from a hook or attachment beneath the instrument. This design minimizes contact points, reducing friction and enhancing sensitivity. Hanging balances excel at measuring small masses with exceptional accuracy. Imagine weighing a single drop of water or a tiny insect wing. These balances can handle such delicate tasks with ease. They are particularly useful in fields like chemistry, where precise measurements of reagents are crucial for experiments. Additionally, industries dealing with pharmaceuticals, materials science, and nanotechnology rely heavily on these balances for their research and production processes. Section 5. Top-loading balances, precision for the everyday alchemist. While hanging balances excel in specialized settings, top-loading balances are the workhorses of the weighing world. These versatile instruments find their place in classrooms, kitchens, and industrial environments alike. Top-loading balances feature a weighing pan located on top of the instrument, providing easy access for placing objects. Their design prioritizes stability and user-friendliness, making them suitable for a wide range of applications. From measuring ingredients for a culinary masterpiece to determining the mass of a package for shipping, top-loading balances offer convenience without compromising accuracy. They are also commonly found in educational settings, introducing students to the world of precise measurement. Whether you're a student conducting an experiment, a chef perfecting a recipe, or a business owner weighing products, top-loading electromagnetic balances provide the reliability and ease of use you need. Section 6. The ritual of calibration. Ensuring your balance is in tune with the cosmos. Even the most precise instruments require calibration to maintain their accuracy. Think of it as tuning a musical instrument. Just as a piano needs regular tuning to produce harmonious sounds, an electromagnetic balance needs calibration to provide reliable measurements. Calibration ensures that the balance's readings align with known standards. This process involves using certified weights, carefully calibrated to specific masses. To calibrate your balance, start by ensuring it's clean and level. Then, following the manufacturer's instructions, place the appropriate calibration weight on the weighing pan. The balance will then adjust its internal settings to align its reading with the known weight. Regular calibration is crucial, especially after moving the balance, experiencing significant temperature fluctuations, or suspecting any impact or vibration that might have affected its accuracy. By performing this simple yet essential ritual, you ensure that your balance remains a reliable tool for precise measurements. Section 7. Maintaining cosmic harmony. Caring for your electromagnetic balance. An electromagnetic balance, while a marvel of engineering, requires care and attention to maintain its cosmic harmony. Treating it with respect ensures its longevity and accuracy. Firstly, cleanliness is paramount. Just as a telescope's lens must remain spotless for optimal stargazing, the weighing pan and surrounding areas should be free from dust, debris, and spills. Use a soft brush or a lint-free cloth to gently remove any particles that might interfere with measurements. Secondly, handle the balance with care. Avoid dropping, jarring, or subjecting it to excessive vibrations. Remember, it's a precision instrument, not a percussion instrument. Treat it accordingly. Thirdly, be mindful of the environment. Extreme temperatures, humidity, and air currents can affect the balance's performance. Choose a stable location away from direct sunlight, drafts, or heat sources to ensure optimal operating conditions. Section 8. Cosmic precautions. Navigating the delicate dance of precision. Even with proper care, certain precautions are essential when working with electromagnetic balances. These instruments are sensitive, and understanding their nuances ensures accurate and reliable results. Firstly, be aware of static electricity. Just as static can disrupt a radio signal, it can also interfere with the delicate measurements of an electromagnetic balance. Ground yourself before handling the balance or the objects being weighed to discharge any static buildup. Secondly, avoid overloading the balance. Each balance has a maximum capacity. Exceeding this limit can damage the instrument or affect its accuracy. Always check the manufacturer's specifications and stay within the designated weight range. Thirdly, remember that even the smallest air currents can influence measurements. Avoid drafts, sudden movements, or even breathing directly on the weighing pan, especially when dealing with minute masses. Section 9. A universe of applications, electromagnetic balances in action. Electromagnetic balances, with their precision and versatility, have become indispensable tools in a vast universe of applications. From laboratories to factories, kitchens to classrooms, their influence is felt across disciplines. In scientific research, these balances are critical for precise measurements of reagents, samples, and products. Chemists, biologists, and physicists rely on them for experiments, analysis, and discoveries that push the boundaries of human knowledge. Industrial settings benefit from the accuracy and reliability of electromagnetic balances in quality control, production, and research and development. From pharmaceuticals to food processing, these balances ensure product consistency and adherence to strict standards. Even in our homes, electromagnetic balances have found their place. From precisely measuring ingredients for baking to determining postage costs for packages, these balances bring laboratory-level accuracy to everyday tasks. As technology advances, we can expect even more innovative applications of electromagnetic balances in the future. Their ability to measure minute masses with exceptional precision holds immense potential for fields like nanotechnology, materials science, and beyond.